Have you ever gazed at the night sky and wondered what lies beyond that milky band of stars? That's our home, the Milky Way galaxy. For all of human history, we've been bound to this one planet, orbiting one star, inside one galaxy. But we're explorers at heart. We've climbed mountains, crossed oceans, and even set foot on the moon. The next leap? Venturing beyond our own galaxy. Intergalactic travel is the ultimate dream, an expression of our curiosity and desire to experience the universe firsthand. But the universe is vast, and its scale is almost unimaginable. To even consider leaving the Milky Way, we must confront the crushing distances involved. Physics seems to lock us in, but it might also offer a key, a loophole, a cosmic shortcut. This is where the conversation shifts from rockets to the very fabric of the universe. We're talking about bending space and time, about theoretical gateways called wormholes. These ideas aren't just fantasy, they emerge from the most powerful theories in physics. So let's embark on a journey of the mind and explore the science behind these cosmic tunnels. Can humans ever leave the Milky Way? The answer is a story about science, dreams, and our place in the cosmos. Let's get started. The Milky Way is enormous, 100,000 light-years across home to hundreds of billions of stars. Light, the fastest thing in the universe, would take 100,000 years to cross it. The nearest major galaxy, Andromeda, is 2.5 million light-years away. Even at light speed, it would take 2.5 million years to get there. Our fastest spacecraft, the Parker Solar Probe, would need over 5 billion years to reach Andromeda. By then, our sun and solar system would be long gone. Rockets, no matter how powerful, are like rowboats in a cosmic ocean. The universe is a prison of distance, with the speed of light as its unbreakable wall. To escape, we need more than a faster ship, we need a shortcut. That shortcut requires a new understanding of space and time. Enter Albert Einstein, the man who rewrote the rules of the cosmos. His theories hint at possibilities far stranger than anything rockets can achieve. If we want to break free from our galactic prison, we must look beyond conventional travel. The answer may lie in the very structure of the universe itself. The next step is to understand how space and time can be bent to our will. Only then can we imagine a way out. The journey to other galaxies demands a revolution in thinking. Let's see how Einstein's ideas open the door to cosmic shortcuts. The story of wormholes begins here. In the early 20th century, Einstein changed everything with his theory of general relativity. He showed that space and time are woven together into a flexible fabric, space-time. Mass and energy bend this fabric, creating what we feel as gravity. Imagine a rubber sheet. A heavy ball creates a dip, and smaller objects roll toward it. This idea explains orbits, black holes, and even GPS. But if space-time can be bent, can it be folded? That's where wormholes come in, a theoretical shortcut through space-time. Picture folding a sheet of paper so two distant points touch, then poking a hole through. A wormhole is that shortcut, connecting distant parts of the universe. It's not about moving faster than light, but about making the distance itself shorter. Enter one end, emerge almost instantly millions of light-years away. The math allows for it, thanks to Einstein's equations. But can such shortcuts actually exist in reality? The concept is tantalizing, but the universe may have other ideas. Let's explore what a wormhole might really be like. The next step, from theory to the strange reality of cosmic gateways. A wormhole, according to general relativity, would have two mouths connected by a throat, a tunnel through space-time. These mouths could be light-years or even millions of light-years apart, or in different universes. From the outside, a wormhole might look like a shimmering sphere, distorting the stars behind it. Approach it, and you'd see your destination stars growing larger inside the sphere. The journey through the throat would defy our normal sense of distance and time. To the traveler, the trip could feel instantaneous, no matter how far apart the mouths are. Wormholes are not vehicles, but features of the cosmic landscape, potential portals. Some theories suggest they formed in the early universe, possibly still floating out there. Finding one would be like discovering a cosmic needle in a haystack, but the possibility excites astronomers. The catch? Most wormholes are incredibly unstable. Even a single photon entering could cause them to collapse instantly, destroying anything inside. Some theories link wormholes to black holes, regions where gravity is so strong nothing escapes. The idea, fall into a black hole, travel through a wormhole, and exit via a white hole, theoretical opposites of black holes. But white holes remain purely hypothetical. We've never seen one. Even in theory, the wormhole would pinch off too quickly for anything to pass through. The bridge collapses before you can cross. This instability is the biggest obstacle to using wormholes for travel. To keep a wormhole open, you'd need a kind of cosmic doorstop. Normal matter won't do, it would only make things worse. What's needed is something entirely new, exotic matter. Without it, wormholes remain impassable. The next challenge, can we find or create this strange substance? Let's see what exotic matter might offer. To stabilize a wormhole, you need exotic matter, stuff with negative energy density. Unlike normal matter, which pulls things together, exotic matter would push space-time apart. It's anti-gravity in action. If we could line a wormhole's throat with exotic matter, its repulsive force could keep the tunnel open. The concept is purely theoretical, but hints exist in physics. The Casimir effect, for example, creates a tiny region of negative energy between two metal plates. But the effect is minuscule, nowhere near what's needed for a traversable wormhole. We'd need vast amounts of exotic matter, and we have no idea how to create or collect it. The quest for intergalactic travel is now a quest for exotic matter. If we solve this puzzle, the universe could open up. Without it, wormholes remain mathematical curiosities. The search continues both in theory and experiment. Could we ever build a wormhole in the lab? Let's look at the first steps scientists have taken. For years, wormholes were just theory and science fiction. That changed in 2015, when Spanish scientists created a magnetic wormhole in the lab. This wasn't a tunnel for people or matter, but for magnetic fields. Using metamaterials, they built a device that let a magnetic field disappear at one point and reappear at another, with no trace in between. It was a proof of concept, a real-world analog of a wormhole. This experiment showed that the geometry of wormholes can be recreated using electromagnetism. It's a long way from a gravitational wormhole, but it's a start. These lab analogs let us study wormhole properties in controlled settings. Each step brings us closer to understanding how such shortcuts might work. Human ingenuity is turning imagination into experiment. The journey from theory to reality has begun. As we dream of intergalactic travel, new leaders in space exploration are emerging. India's ISRO has achieved remarkable feats with limited resources, from lunar landings to Mars missions. Their philosophy of efficiency and innovation is exactly what future space exploration needs. Imagine a future where wormhole science advances. Who will lead the charge? With its talent and ambition, India could be at the forefront of building the first interstellar probes. The challenges ahead will require global cooperation. India's achievements remind us that great dreams are fueled by curiosity and determination. The journey to the stars will be a united human endeavor. We've explored the vastness of our galaxy, the strange physics of wormholes, and the first lab experiments. Yet, we're left with more questions than answers. What if exotic matter doesn't exist or can't be created? Are there other ways to stabilize wormholes? Even if we succeed, new philosophical and practical challenges arise. Could wormholes allow time travel? How would it change our place in the cosmos? The quest isn't just about travel, it's about pushing the limits of knowledge. Even if we never build a traversable wormhole, the pursuit will lead to discoveries we can't yet imagine. The obstacles are immense, but so is our drive to explore. We look at the stars and dream of reaching them. The universe is more complex and magnificent